I'm Grant Saviers, trustee of the Computer History Museum, here with Dave Cutler in his living room in Bellevue on a beautiful Seattle day. Nice weather for a change. The winter may be ending. To discuss with Dave his long career in the computer industry. And so we'll begin. So we were talking about, before this, your entry into computers, but let's roll back a bit into early childhood and living in Michigan and being near the, I guess, Oldsmobile factory in Lansing. So tell us a little bit about your early days and getting high school and so on.
Well, I grew up in DeWitt, Michigan, which is about 10 miles north of Lansing, where Oldsmobile is at. I went to DeWitt High School. I was primarily an athlete, not a student, although I had pretty good grades at DeWitt. I was a 16-letter athlete. I played football, basketball, baseball, and ran track. And I'm a Michigan State fan. Michigan State was right there in East Lansing, so I grew up close to East Lansing in Michigan State. Early on, I was very interested in model airplanes and built a lot of model airplanes and wanted to be a pilot when I grew up, but somehow that just went by the way. And later on, I discovered I had motion sickness problems anyway, so that wasn't going to make it. So that's pretty much my early.
So the model airplanes kind of kindled a technical interest in aviation and flying and how that worked?
Well, I don't know how I got into model airplanes. There was a local shop that was like a hobby shop that sold model airplanes, and I got interested in building them. And then, of course, you build bigger ones, and you try to build powered ones, and I built the powered ones, and I mostly crashed them. So I don't know if it really fostered a technical interest, but certainly it was something that I was interested in for quite a while. But then kind of sports took over in high school, and I became more interested in sports.
So the sports led to an opportunity to go to DeWitt College.
Olivet College.
Olivet College. And athletics were a big part of making that possible, weren't they?
In fact, I went to Olivet College. They offered me pretty much a full ride. I had an academic scholarship, and I had scholarships for basketball, baseball, and football. And I would probably not have went to college if I hadn't had a full ride, because we couldn't afford it. And I had applied a couple other places. I really wanted to go to Central Michigan, and they didn't accept me. And the thing at Olivet worked out really well. It was close to home, and that's where I ended up.
Mm-hmm. And how did you decide on the course program that you'd take at Olivet?
When I got there at Olivet, I didn't really know, I think like most students, what I really wanted to study. And I don't know why I decided on math, other than it was a very interesting, challenging thing. And then after I decided math was my major, then it was natural for me to say, well, I ought to have a lot of physics. So I took a lot of physics, and I really enjoyed math and physics. I didn't enjoy some of the other things. Olivet is a liberal arts school, so there was a lot of liberal arts requirements. It's also a religiously affiliated school, although really not tightly religiously affiliated, but there was a lot of stuff I had to take that was religious related. But I sort of gravitated towards the math and the physics, and it worked out well.
Great. So that you're progressing through college and thinking about what's next, where the career might lead, where you might go to work. How did that progress? Any jobs during college, by the way?
Did I have any jobs during college? The answer is no. I was so busy playing sports And later on, the first 2 years of college, I played mostly sports and studied just enough to get by and keep my academic scholarship. And then the last 2 years, I really, you might say, applied myself and tried to be good a student. What happened to me was within a span of 18 months, I had my right knee operated on, and they pulled out the medial meniscus. I broke my left leg, and then I had my left leg operated on, and they pulled out the medial meniscus there. So I was pretty much done with sports at the end of 2 years. And during those 2 years, I think that I mainly thought about that I never thought that it was really going to end, that I was going to be, I was just thinking about, well, I'm just going to be playing sports forever. And then after 2 years, it's sort of like, well, I'm not going to be playing sports forever. What do I really want to do? And so I'm really not sure what I really want to do, but I think I really like math and I like physics, and I'm a hands-on kind of person that likes to build things. So I really think that I would like to have some kind of an engineering job somewhere. So I was sort of aiming at an engineering job, not going to an engineering school, in a time era where it was possible that such a thing could happen. Today, that would probably be kind of like pretty remote that somebody could do that. I mean, if you had a math degree, you probably wouldn't step into a mechanical engineering job or something like that. Of course, you could step into a computer engineering job. Computer engineers, a lot of different disciplines make good computer engineers. So anyway, my goal in the last few years was to finish my degree and find an engineering job.
And how did that go? I mean, did you start interviewing companies? Companies come to the campus, or?
In those days, the companies didn't come to the campuses. We're talking 1965, and or at least they didn't come to our campus. And I just mainly applied to a lot of different companies. I applied to Lockheed and the aerospace companies, and I applied to General Motors, and I applied to DuPont. I don't know how I happened to apply to DuPont. I saw an ad somewhere probably or something, and sort of waited for people to come back and, say, hey, we want to interview you. It turned out that I ended up actually having 3 solid job offers. One was from Chrysler in a soft trim plant, which was door panels, and soft trim in an automobile is basically the inside. And I would be the job there was a time and studies kind of operations research kind of job in a town that wasn't too far from where I lived. I had a firm offer from Oldsmobile to work in their computer accounting department. And I had an offer from DuPont to work there in a job that was supposedly an engineering job. So I sort of decided I didn't want to work for Oldsmobile because I didn't want an accounting job. There was no, I didn't know anything about computer science at that time, and computers were around and people used them for records keeping and accounting kind of things. And of course there were people at universities that were using them for other things. But mostly when you talked about computers, the general public knowledge about computers was accounting and records keeping. And that's mostly what the IBM machines were, was record keeping and accounting. So I decided I didn't want to work there either. And so I decided to go to Wilmington, Delaware and take the job with DuPont.
And was that job what you expected?
Was the job what I expected? No. It was a life lesson in interviewing, and that when you interview and you decide you'd like to go to work for a company, you really should pin them down about what you're going to be doing when you get there, because if you don't, you may not be doing that. And I thought I was going into an engineering job a little bit undefined, but I ended up when I got there with a job that was a tech writer, writing standard test methods for DuPont Elastomeric Materials Division, which were basically methods on how you stretch and pull and bounce synthetic rubber.
That's pretty far from computers. What was the first step into computers?
My first step into computing was with a group at the same lab I was at, which was a sales service lab, which helped DuPont customers apply DuPont products to their products. DuPont basically made raw materials for other people to use in developing a project or product. For instance, the elastomeric materials division made neoprene, and neoprene went into a lot of things like wetsuits and even went into tires for a long time. So there was another group there, which was a math and stat group, and I'd interviewed with them and they were interested in me. And after about a year, they asked if I could be lent to that group for a short amount of time to develop a model of a foam process for Scott Paper Company.
Okay, so we were talking about a foam making process at DuPont and some challenges in that led to a computing
So
task.
DuPont was trying to help Scott Paper Company with a new process that they had developed to make foam for the garment industry. And the guy at the lab, the DuPont lab, that was the manager of the math and stat group, wanted to build a model to help them schedule the production on this new machine. And so they asked if I could do that model, and I said, yeah, I do that, because I was so bored to tears trying to write these test methods that nobody seemed to like what I was writing. So they sent me off to school with IBM to learn a language called GPSS3. GPSS3 was General System Simulator 3. General
Purpose System Simulator.
Yeah, General Purpose System Simulator 3, which was their third version of this. GPSS is a language that's an event-driven, block-oriented language where you have a number of different blocks, or you could look at them as functions that perform a specific kind of thing, like create transaction was a block. So you could create transactions into the system that you're trying to simulate.
And these all operated in parallel too, right? It was a parallel event language, if I remember right.
Yes, it is. I'm sorry. It is. The language tried to simulate a real-time process, a real-time system, mm-hmm. And everything was running in parallel, but there was no need for synchronization. So you were kind of removed from the synchronization aspect of building this model. And I ended up building a fairly large model, and partway through the building of the model, I got really interested in more about how the computer worked than how the model worked. So I began to really dig in a lot about the computer architecture of the machine I was running on. The machine that we ran this model on was an IBM 4044? 70, yeah, it's a 4044.
7440, maybe.
No,
anyway.
It was the precursor to the 7094.
Well, 709.
So maybe it was a 7044, that's what it was.
Yeah, 7044.
7044,
yeah.
It was a 36-bit machine. And this is the time that I really learned how fallible humans are, and learned a lot of humility about programming, and the fact that computers only do exactly what you say and not what you mean. And I went up to the IBM data center. We had to go up to Philadelphia to go to the IBM data center, and with my deck of 2,000 cards, with all kinds of time, free time this time, scheduled, with the IBM representative and my boss and everything, and we're jolly going up there, and we're going to run this model. And we get there, and we spent all the time trying to take the syntax error out of the program, and we never got them out the first day. So that was a really humiliating experience.
So the GPSS project finally worked, and you delivered some.
The GPS project, our GPSS project, ran for, I think, about a year, and we had somebody from Scott Paper assigned to work with me. That actually was somebody similar to me, very little experience, and a young guy. And he and I would go up to the data center and run this model, and we would feed information into it and try to get results out. And what we were trying to do was we were trying to figure out how or what the best schedule was for scheduling a number of different colors and textures of foam on this machine to get the best productivity out of the machine. And we, eventually we got the model to work, and we said, okay, give us a question to ask the model, and they came up with a question about scheduling, and we ran that, and we had, a big presentation, and we handed over the model to them and said, okay, here's the model. All you have to do is go to the IBM data center and run this, and you have a guy that can run this. And I really don't know what they did after that. I suspect they did very little with it, but it was sort of a lot of it was public relations on DuPont having a vested interest in seeing that Scott Paper Company had the best support they could possibly get to run their foam process.
Right. So this initial foray into computers then leads to digging deeper into how computers really work and how operating systems really work.
So after this project, I sort of, got more interested in computing and decided that I would really like to stay in the math and stat group. So I stayed in the math and stat group and worked on various things. We had a 1108, well, it was 1107 to start with, a UNIVAC machine at the experimental station, which was, 15, 20 miles away, and there was a shuttle that ran back and forth every day, and we could submit programs to run on that computer and get the results back. So I started doing some of that stuff for the math and stat group, and I also got involved with procuring a CDC 1700, which is a 16-bit machine, to automate the Instron machines, which was a tensile strength testing machine for the lab. And so I got pretty interested in that. And this all lasted, I would say, maybe about 2 years, and then I started to think about, I really wanted to be somewhere where I was working more on computers rather than working on computers as a tool to solve other problems. So I succeeded in negotiating a transfer to the engineering department of DuPont, which had lots of computing capability, and they're the ones that had the 1107, which they upgraded the 1108, and I joined the online systems group there.
So the 1108 and 1107 had a product called Exec 2, which was kind of notoriously flaky.
Well, what did I do in the online systems group? Basically, I was trying to help the engineering and service division, which the online systems group within, was trying to help the operating departments, the operating plants within the elastomers department. Actually, with the engineering department, it's the whole company. So there was 13 operating departments. So they're trying to help them with their computer process control needs within the company. But there was a lot of downtime because we were project oriented and we were trying to go out and sell our services to somebody. So there was a lot of time when there wasn't much to do. So I sort of had got interested in the 1107 and 1108, and I went to the system programming group and asked them if there was anything I could do for them. And they said, well, yeah, I could probably help them figure out why Exec 2, which was the operating system for the 1108, was crashing so often. So they said, what we want you to do is figure this out, and every time the 1108 crashes, we take a dump, and a dump is about 4 inches of fanfold paper, which is a I think octal dump, and we want you to figure out why or what's wrong with the system. So at times I would have a stack of these dumps that was 6 feet high in my office, and looking, trying to figure out what the pattern was for this, and I found several problems that were our fault being DuPont's, because we made, I would say, about 2,000 lines of modifications to Exec 2. But I never really did figure out what was really wrong. And I guess an interesting side story is that later on, when I was working at Microsoft in the early 80s, or the early 90s, somebody from the University of Washington in St. Louis did a study on the timing of the 1108 and came to the conclusion that it would go metastable every 4 hours because of the synchronizers in the system didn't synchronize all the clocks properly. So I guess that was the real answer to why it was so flaky.
So this is kind of immersion by fire into what an operating system is.
It is, and I spent a lot of time on the. I should say. Let me say, this was trial by fire. I was at the end of trying to figure out why something didn't work, which made me figure out how it worked. All right, so I had to figure out how it worked to find out why it didn't work. And I'd be in these dumps, and I'd trace back in the dump, maybe 1,000 instructions, and then the trail would just poof, it's gone. Like, it's just gone. So eventually they got to the point where they trusted me enough that I actually became one of the main people that maintained the system and made improvements to it, what we thought were improvements, and put in DuPont specific changes to streamline the operation of the 1108.
So this is now, I know something about operating systems, and I want to take my career further in that direction.
Operating systems really interested me, and I don't know why I decided that, boy, that was the way I wanted to go, but it was really the way I wanted to go. And maybe I didn't know it exactly at that point, but I sure, some of the most satisfying time I had was on the 1108. And then the online system part of it actually kicked in at one point, or a couple points, where we did get some big things to do. We got a big job to work on at the experimental station, which was DuPont's main research center, which is a fairly big site. It was 120 acres, and all 13 operating departments had offices there. So they decided that they would like to automate the analysis of some of their instrument data, and we proposed a dual PDP-10 system to do that. We spent, I don't know, maybe 6 months with various other vendors, IBM being a vendor, SDS, if you remember SDS, Scientific Data Systems being a vendor that we looked at, the Sigma 5, and we decided the PDP-10 was the best alternative. So we bought a PDP-10, a dual PDP-10 system with shared memory, special built by Computer Special Systems at DuPont, or not DuPont, Digital. And then we wrote an operating system for one of them, which was really the front end. And it brought in all the data, and then when the data was complete, it submitted it through the shared memory directly to the TOPS 10 system, which then did the analysis of programs written in Fortran, and then we shipped the results back. So I got quite a bit of experience on DEC PDP-10s, became pretty knowledgeable about the TOPS 10. I went to a school on TOPS 10, which was run by Dave Plummer, which was Digital's #1 guy about running courses on the TOPS 10. So after that, I came back to the engineering department, and they gave me another job that was on DEC equipment, which was a PDP-11 gauge control system for Kronar film, which was used in magnetic tape. And this system was a PDP-1120, and At that time, there was no suitable operating system from digital, digital. No suitable operating system from digital that would actually do this. We were going to do this on a very small PDP-11. I think it probably only had 8K of memory. So I was given the task of developing the little runtime, the little real-time runtime system to do the Kronar gauge control system. So when I finished that, I sort of decided that maybe it was time for me to move on and think about something else. In fact, what I was thinking about was I'd moved from using computers to solve problems to actually working on computers themselves, but not within a computer company. And I thought, well, if I really want to maximize my value to a company, and I want to be in the operating system business, I ought to go to a company that builds computers. So I arranged an interview with Digital in Medina, Massachusetts, and lo and behold, they hired me. So off to Digital I went.
Just backtrack a little bit here. What did you think of DuPont in the year you were there for 6 years, and an interesting culture?
I was at DuPont for 7 years, and the culture at DuPont was very kind of like really foreign to me because it was it was an old company. DuPont was founded, I think, in the mid-1800s. They supplied black powder during the Civil War. That's how they got their start, was black powder. A very bureaucratic company, very regimented. You didn't tend to do things like go talk to your boss's boss. So it was, you know, I had a good time at DuPont, and it was great for my career, but I didn't feel as comfortable there as I actually ended up feeling at DEC, which was a very different kind of company.
So did you have a sense of what the DEC culture was like when you decided that it was time to move to there?
When I went to DEC, I had absolutely no idea what the culture was, other than the fact that I had went to the PDP-10 programming course, so I was a little bit acclimated to the facilities that were all. The Digital was in a mill, and the mill was old. It led back to the mid-1800s also. But not really anything about the culture. I never really thought about that. I think I thought more about the opportunity than I did about, was the culture going to be the same or different? If the culture had been the same as it was at DuPont, I still would have went because the opportunity was better.
So, talk a little bit about the getting started at DEC. Who was your first boss, and what was the direction of the task at hand?
My first job, well, let's back up a little bit about what I was hired for at Digital. This is kind of like maybe another instance of not knowing exactly what you'd end up doing, although I really had this one tied down, and I was going to work on something called OS-45. And OS-45 was a dream of Dave Stone's, who was the head of programming at Digital. And the 45 had some special solid-state memory that you could buy that was 300 nanosecond memory. And this is in 1971. And the PDP-10 was, at that time, I think the best the PDP-10 was a above microsecond machine. So this was a very fast machine, and Dave Stone had this vision that we were going to recreate TOPS 10 on the 45, and we were also going to incorporate real-time real-time capabilities and batch capabilities in addition to the time sharing. And there was a group of people that was assembled that was probably about 8 people, and the leader of the group and my initial boss was Peter Van Rokens. Peter came from RCA, and he was responsible for the development of VMOS, which was the virtual memory operating system that ran on the RCA IBM compatible machines. And So I came to digital, and I spent probably the first 2 or 3 months thinking about all this stuff, and the group was thinking about all this stuff. And then all of a sudden, we weren't really making a lot of progress on this because there was one little small problem that Dave Stone hadn't really considered as much as he really should have, and that was that the address space of the PDP-11 was 65K bytes. And 65K bytes just wasn't going to cut it for an address space, and the memory management capabilities weren't that great either. So we had an awful hard time really getting started and getting up to speed on what we were going to really do with this OS-45. So there was another project that was going on over in the industrial products group, develop a process control system for, or a process control OS for the PDP-11. It was called RSX-11C. And they had been working on that for a couple years, and it was going nowhere, and they asked me if I would go work on that. And I said, well, yeah, sure, I guess I will go work on that. You know, we're not doing much on this other project, so the first project I worked on, really, as far as real work, was the RSX-11C system.
And the RSX-11 series ended up CDM or something like that, if my recollection is correct.
RSX-11C was the kind of like the first in the series of the RSX systems, which were primarily sponsored by the Industrial Products Group, but were also sponsored by the Laboratory Data Products Group also, because they were in the real-time business. And RSX-11C was really kind of like just a core-only system that supported a few peripherals, A to D converters, terminal interfaces. That was about it. And so there was a real need for some more functional systems. And as we filled out the PDP-11 line, of course, the 45 was a pretty big machine, but we filled it out with a lot of other ones too, the 1140 and 45, well, yeah, the 45, the 1170. There was a need for some more machines or more operating system capability that supported a more rich programming and capability. And so there were several RSX systems. There was RSX-11C, there was RSX-11B, which maybe that one may have never had anybody really know much about it, but it was basically RSX-11C that could load DOS 11 files off of the disk. So it was sort of like we can store programs on the disk and run them, but it's still a core-only system. And then RSX-11M and RSX-11D, the order in which we did these was RSX-11C was done first, and then B. And when I did B, I said, I will do B, but I want you to promise me that I don't have to work on this again. And they said, okay. So at about that same time, RSX-11D was starting up, which was an equivalent of RSX-15, which is the 18-bit real-time system that Digital sold. And so I was assigned to work on that. And there was a fellow named Hank Krejci, which was the main designer of that because he worked on the RSX-15. And I agreed to do the overlay linker for it. So my involvement with RSX-11D was the overlay linker. And when we finished that, that came out a little bit larger than we hoped and a little bit slower than we'd hoped. So I had this idea about building a system with a really different architecture. The RSX-11D had an architecture where basically everything ran as a process. And doing that meant the drivers ran as processes, which meant that there was an IPC, an inter-process communication mechanism had to exist between the program that wanted the service of a driver and the driver, which wasn't really conducive to the real-time performance we wanted to have. So I had this other idea of building a system that was a lot different. In fact, it's mostly like the other systems that we built or I've been involved with. So I proposed building RSX-11M. And the industrial products group got pretty excited about it, and they gave me, I guess, about 8 people to work on that, and we completed that in about 1.5 years or 2 years. And that became the main real-time system for PDP-11s because it would run on all the PDP-11s. The ones that had memory management system, or memory management units, and the ones that didn't. In fact, it ran on systems from 32 kbytes up to 2 megabytes, a big span.
So this is the first time that you're running a major software project, right? A major operating system development project.
Was this the first time that I was running a major project? Probably you would consider that to be the first time of a major project because this was something that we're actually going to sell. We're going to sell RSX-11M. We're going to have customers. We're going to have support issues. And so there's all of that. And we're going to have documentation to do. The PDP-10 system was probably not quite as big a project, but I was the lead guy there too. Very inexperienced. I don't know how DuPont ever had the faith they had in me to do that, but they did, and I'm thankful they did. So RSX-11M was really the first time that I did a project, and so I developed around RSX-11 a lot of things about, how are we going to do this, and what are we going to do, and what do we have to do, and so one of the first things I wanted to know is, what is the scope of work? What are we going to do? You can't just say we're going to do an operating system. We ought to know, well, what capabilities it's going to have, what are its constraints. One of the constraints it had was it had to be subset compatible with RSX-11D. So it wasn't a blank sheet of paper where we could just go off and do a new system. It was, well, it has to be subset compatible, but it's source level compatible, not binary compatible. So that was a big caveat because binary compatibility is much harder to achieve. So RSX-11M was really my first real operating system from scratch. I think it took about 2 years. It was delivered with what I think was pretty good quality for the tools and everything we had at that time. My philosophy about quality was number one. It's still my first thing, is quality number one.
So the size is the gold rubber stamp played into that, or?
One of the big constraints with RSX-11M was, or one of the big problems with RSX-11D was it required so much memory. So with RSX-11M, we wanted to build a much smaller system, and I kind of figured out right off the bat that the only way to do that was we give everybody a budget. So everybody had a budget about how much memory they could use. And, if somebody, so that was their target. So if somebody came back and said, I can't possibly do that, and, whatever the budget was, then we'd rethink that. But generally, everybody meant their budget. And so to kind of reinforce that, I had this rubber stamp made that says size is the goal. And everything was stamped with size is the goal. In those days, there was no email, so there was no electronic exchange of communication, so all communication was through memos, and every memo was stamped with size is the goal, size is the goal. So we ended up with, in a 32 kbyte system, there was 16 kbytes for the operating system and 16 kbytes for whatever the user environment was, or the application environment. There wasn't really user mode, and there was user mode and kernel mode, but these were dedicated systems. It wasn't a system where there were a lot of people going to use this in a general way. It was like this system is dedicated to controlling something in a real-time way, and whoever bought the system would write the software that would control their process.
Now, this is where the first Dave Cutler kernel, the DCK, shows up. You go off and code a big part of the operating system yourself?
Well, all the stuff that I worked on, I did a lot of it myself. I did, going back to the PDP-10, I did a lot of that myself. In fact, everything that I've done throughout my career, I've always been a very hands-on person. I can't just stand back and say, you know, this is what we're going to build. You guys go off and write the specs, and I'm going to manage you. I sort of become part of the team, and I look at myself as more of a leader than a manager. And I want to lead the people to build the product, and that means I'm a part of that. And there's no job that I won't do. I have this little saying that the successful people of the world are the people that do the things that the unsuccessful ones won't. So I've always been this person that, you know, I will build the system, I will fix the bugs, I will fix other people's bugs, I will fix build breaks. It's all in part of getting the job done.
So the 11's running out of gas. DEC decides it's time to build a 32-bit computer. They're behind SDS and SEL and others in 32 bits, and a new operating system is needed, and VMS starts off.
I think it was 1975, Digital realized that they needed to build a 32-bit computer. And so being a part of RSX-11M and the 11 world, I kind of got involved in that. We had several architecture groups, several levels of architecture group. We decided to call this VAX, and VAX was a code name which stood for Virtual Address Extension, because the PDP-11 had such a small virtual address space. And Gordon Bell was the person that was behind this. It was his vision that we should build this computer. And VAX A was the hardware architecture group, and VAX B was sort of a review group. And then I think there was another one called VAX C, which was kind of like the rest of the company. And I was like a formal member of VAX B, but an informal member of VAX A also. So I spent a lot of time on the VAX A group discussing the computer and whatever. And Bill Strucker was involved in this, and Gordon Bell. This is my first real involvement with Gordon. He was definitely at the company all the time I was there, but this is the first time I was really involved with him. And we would meet almost every day and talk about this computer and the instruction set and what we should do. And one of the biggest goals of VAX was to be able to encode a program in the same amount of memory that the PDP-11 could encode it. So that sort of dictated a instruction set that was pretty dense. The other thing is we definitely wanted to increase the virtual address space by quite a bit, and building a 32-bit computer would allow us to do that. And at that time, like going from 16 to 32 was like, man, how could we ever run out of 32 bits of address space? And later on we'll skip forward and we'll figure out why we did run out of 32 bits. So the VAX A and the architecture group basically were defining the architecture, and there were other software people involved. There were some people from the PDP-10 group that were involved, mainly Peter Conklin, and we hired a fellow from Xerox who had worked at SDS, who had worked on a system called CP5, which was one of the systems that ran on the Sigma 5. It was the operating system of the Sigma 5. His name was Dick Husfeld. Dick was involved with VAX A, and the other person was involved with Peter Lippman. You know, there were some other people, but we basically developed the architecture, and then the company said, well, let's build it. And so we sort of said, well, how long do you want this to be? And they said, well, 2 years seemed reasonable. And we said, oh my Lord, we can never build this in 2 years. This is too complicated of an architecture to build in 2 years. So we had this off-site 1 week come to Jesus meeting about what we would do to the architecture to make this system buildable in 2 years. And I think that was called the Blue Ribbon Committee. And there was 3 software people and 3 software implementers and 3 hardware implementers, plus some of the architects. And we hammered out the final VAX architecture, which reduced the complexity of the the instruction set architecture quite a bit. I suspect that people would still say that the instruction set architecture was overly complicated, but it was really complicated before that. And the other thing that happened was the memory management was so complicated that the only person that could actually explain it was Richie Larry. And everybody else was sort of like, yeah, that seems like it might work, but we're not really sure. And so we really simplified the memory management architecture so that the hardware architects thought that they could build it efficiently, and the software people thought that we could build an operating system for it. And one of the decisions we made with VAX, in fact, we made a couple of decisions with VAX that limited the life of VAX. One was the encoding of the instruction stream to be equivalent to the PDP-11, which caused it extremely difficult to implement hardware system that was mainly in hardware and not mainly in microcode. So the VAX instruction set mostly was executed in microcode and not in hardware because it was so hard to decode. And the other thing that was kind of a mistake, a long-term mistake, was the page size being 512 bytes versus something more reasonable like 1K bytes or 4K bytes would have been a much better solution. However, we looked at it, and the marketing people wanted to sell VAX systems that were the size of PDP-11 systems in memory. So they wanted to sell a system that was 128K bytes. Well, the most complicated instruction in the VAX architecture was add pack 6. That was an add packed instruction, decimal instruction with 6 operands. That could touch 40 pages. So it became, if it has to touch 40 pages and you only have 128K bytes, then you don't want to get into a live lock situation where what's going on in the system is such that you can never get all the pages in to actually execute instructions. So we settled on the 512 byte instruction set. So after the architecture was kind of signed off on and we decided we really want to build it, we went through the Blue Ribbon Committee, published the final architectural spec, then we put together the software group and we put together the hardware group to build the hardware and to build the software, and I was the technical lead of the software group. And then we went off and spent, I would say, 6 months trying to think about and understand how to build the system because we were death afraid of building a paging system. There wasn't a lot of experience on paging systems in those days. The PDP-10 did not have paging, it had swapping. BB&N had built a modification to the PDP-10 which had paging, but the scuttlebutt was it didn't run real well. Multics was a paging system, and Multics did not run well. I'm not sure that Multics would run well on today's hardware. It was a great system. It spawned a lot of creative ideas, but it was basically very slow. Anybody that ran on that system definitely was not concerned about productivity. So we spent a long time figuring out how we would build this system so we thought we would have good performance. We would be able to build it in a couple of years, and we would have the quality that we wanted to have. And so after 6 months, we authored a document called, I think, the Starlet Design and Project Plan. Well, it was a Scarlet Project Plan. And from that, we started out and we implemented, we developed VMS mainly on RSX-11M. And RSX-11M had a little bit, by that time, it had a little bit of time sharing capability, so there was multi-use, and we had a large 1170, probably two megabytes of memory on it. 2 megabytes. So we developed mainly on RSX-11M, but then we ran it on a simulator. The group that actually built the VAX 11750 was the group that was assigned to build the emulator for VAX, and we actually had an emulator to run on, which was a hardware emulator. So we didn't run on a simulator, we ran on an emulator. And we developed it, I got it running there, and then when the hardware, the breadboard for the 1170 was available, we took what we had and we went upstairs, and it pretty much ran. It booted up, and at least we got to the point where I didn't crash. So that's kind of how we started. And then from then on, they built a prototype. I think it was Proto 4, and that was our development machine. And everybody ran on the development machine, and we ran what we built. And this is the first instance of the dog food thing, where you run on what you're developing, and that gives you a big incentive to fix whatever's wrong. So we would, we're all sitting, and VMS is a time sharing system. So we were all in our offices, and all close to the machine, and if it crashed, Dick Husfat and Peter Lippman and I would go out and look to see why it crashed. And we'd figure out why it crashed, and we'd reboot, go back to our office and fix the problem, and then go out and reboot a new system, and then everybody would be with a new system. So that's sort of how the development of VMS occurred. And the day we shipped VMS, we had 0 known bugs. Now it was 0 known bugs. That didn't mean there was no bugs, but there were 0 known bugs. And I know there was a bug right at the very end where we had a race condition that was fixed like in the 11th hour, and then the final binaries were submitted to the manufacturing plant.
So the VMS in the 780 kind of launched DEC into the super mini, bigger applications, more nudging into the commercial world, all kinds of new features and requirements coming, and that spawns a lot of evolution of VMS. So you were with the VMS team.
Well,
all of that.
No, when VMS was what was my first very difficult project, where there were some constraints placed on us that were very very hard. The 2 years that we were given to eventually or effectively produce a system of the level and caliber of VMS was very short. And at that point, I thought maybe I should try some other things I'm interested in. And one of the things I was very interested in was compilers. So at the end of VMS version 1, I decided that I would start a compiler group to produce a PL1 compiler. So I really didn't continue on with the continuing versions of VMS. I split off at that point and started this group consisting of, I think, 4 people, and I think we grew to about 6 people to do a PL1 compiler. And we bought a front end for the compiler from a company in Boston, and we produced the back end, which was the code generator. And I think that was another 2-year project or so. And part of that project also spawned a C compiler for VAX also.
And this was an example of really eating the dog food of writing the compiler in PL1?
Actually, PL1, as far as a dog food kind of thing, was an interesting way we did the compiler. We had the front end of the compiler that was delivered to us on Multics. And Multics, we first thought that what we would do is we would take the Multics compiler and we would compile the pieces of the Multics compiler, and we'd bring them over to VAX and run them eventually. We tried running the remotely on the Multics system, and we couldn't get it to run in full duplex mode. And this was like, I don't know, 100 or whatever, it's 50 miles to Boston. It's 300 baud. So we tried half duplex. It was a little bit of half duplex, so that wouldn't work either. So we decided what we would do is we'd hire a shuttle service, And the guy that was working on the front end would produce stuff on Multics, put it on mag tape, give it to the shuttle service, bring it to DEC, and we'd take it off the mag tape. So the first thing we did was we bootstrapped the compiler backwards. So we were doing the code generator on our end, but the code generator was mostly written in assembler. So we got that working, and then we would bring back the phases of the compiler one by one backwards until we got back to the beginning of the compiler, and then we could compile the whole thing at digital. So we really were eating our dog food because the whole compiler was written in PL1 except for the parts of the code generator that had to run last.
So now we're about 1981 at DEC or so, or a little earlier.
This is about well, it's 1980, 81, sometime during that year, maybe early in that year.
So some circumstances conspire, and Dave says, Maynard's no longer for me.
Pardon?
Maynard was no longer for you.
So what happened after the PL1 compiler was, I sort of getting really a little bit fed up with the growth of digital. When I started digital, there was 12,000 people, and I don't know, in 81, there certainly wasn't 12,000 anymore. There was 75,000 or something. And so what started out to be this really engineering environment suddenly became more of a management, marketing, program management environment, which I wasn't too happy with. And so I had expressed some things to Gordon about maybe that I would like, to be somewhere else. And he had offered to, he said, well, anywhere you want to go, maybe we can figure out how we can start an engineering facility there. And I'd said, well, I don't know, maybe I'll be okay here. And then this opportunity came up to start a company that was going to commercialize a language that was funded by the government for real-time control, which was called Praxis. And it was done for Lawrence Livermore. And it was actually done for the Shiva Nova project, which was a fusion energy project. So I kind of got enthused about doing that, and we being, I guess, about 6 people, 3 of us from DEC and 4 of us from DEC and a couple from Lawrence Livermore, traveled around the Bay Area looking for money. And we sort of got to the point where I think we figured out that maybe this wasn't the right thing to do, or at least I figured out this wasn't the right thing to do. And so I had told Digital I'm leaving. And so, we had a termination date and everything. And then all of a sudden I think, I'm not sure this is going to work out. The president of the company was going to be a guy from the Shiva Nova project, and he seemed to be more interested in how he was going to spend all of our seed money, which we had put up ourselves, on things like his colors and his wife, paying his wife for our stationery. So suddenly all our money that we'd put together was gone. And I'm thinking, wow, I don't know if I want to go with this guy. So at the last moment I said, no, I'm not going to do it. So effectively all the other DEC guys says, well, we're not doing it either. So then became the question about, well, geez, what are you going to do? And so I said, well, I think it's really appropriate that I think about being somewhere else where I'm kind of isolated a little bit from a little smaller environment where we don't have all of the bureaucracy or we're developing a DEC. So Gordon says, well, geez, that sounds good to me. Where would you like to go? And I said, well, can't be on the East Coast because that won't be far enough. I really don't like the Southwest too much. So maybe, like Arizona and New Mexico. Probably Texas is not a good place. Probably the West Coast would be the best place. Well, Gordon says, the West Coast would be fine, but I want you to be somewhere where there's a university that's got a good computer science program, so that we can draw people from there, and maybe we can actually collaborate with the university. So the DEC real estate department arranged this trip where we would fly to several different places on the West Coast and look at, and we went to San Francisco, we went to Sacramento, they were really hot on Santa Rosa, we went to Portland, and we came to Seattle. And I had spent a little time in Portland a little earlier. In fact, what had spawned the earlier offer by Gordon to establish an engineering facility for me was that I had actually interviewed at Intel in Portland, and which is kind of an interesting, this is kind of a backtrack, but let me go back and talk about that just for a second. And this happened, and I interviewed, and they were building the 432 at that time, which was their 32-bit computer, which eventually never ever materialized. But we had lost a couple people. Dave Best, who had been the program manager for the 750, went there. So I interviewed out there, and they got to the point of they were going to offer me a job, and they said, well, we can't really offer you a job because we really cooperate a lot with digital, and you've got to tell Gordon Bell that you're interested in this. So I said, no problem. So we're at Spitbrook Road. I call up Gordon. I said, Gordon, I've been interviewing with Intel, and I don't really want their job, but I want their offer because I want to figure out how much I'm worth. Is that okay? You okay with that? And he says, sure. And I hung up, and about 15 minutes later, the phone rings, and it's Larry Portner's admin. Said, Larry and Gordon would like to come up to Spitbrook and have lunch with you. And I said, oh, that's fine. When? Today. Will that be okay? And I said, sure. So they came to Spitbrook and said, we went to lunch, and they basically said, well, why do you want to leave? And I said, well, I don't want to leave. I just want to know what my value is in the market. They said, oh, well, maybe we can work something out. And then that's when Gordon said, I said, I really like Portland. And Gordon said, well, maybe we can think about this. And so, we did something about the salary thing, and we did something about stock options, and we thought about that a little bit. And then I said, hey, I don't really want to do that. I'll stay here for a while. And then this other company opportunity came up. And then when that fell through, it was really like, I really do want to move. So anyway, we're back to the West Coast. We're going down the West Coast, and we go everywhere, and we come to Seattle, and it's raining, but everything's green. And I said, gee, boy, this is really a nice place. And we visited the university. We talked to the head of the chairman of the computer science department. I forget what his name was. He was really interested in us coming. And so we went back home, and we thought about it for a while, and said, Seattle's got to be the place. That's got to be the place. So that's how we ended up in Seattle. We took the trip and looked at some different places, and decided we didn't really like Sacramento very well. The Bay Area was a little bit too busy for us. And Bellevue was a pretty nice place to be, so that's where we ended up.
So here you are. So a number of people decided to come with you, and then some other folks were hired here locally. You started up a lab.
We came here, and we brought, I guess, about 8 people with us. And we hired, one of the things was we would like to hire some people from the University of Washington to firm up that connection of the University of Washington. We hired a couple people from there and started on a project to, our charter, by the way, for this was to produce, again, going back to the real-time roots, to produce some software for embedded chip-based vac systems. We were working on a chipset at that time called Scorpio, which by today's standards would have been huge because it was 6 chips. I think 3 of them were custom VLSI chips. So it was been big compared to today. but it was very small compared to what we had in those days. So our charter was to build this runtime system, or little real-time operating system, which was very easy to program and which was very easy to implement real-time applications. And the name of the system was Vaxilon, and it was my first entry, or our first entry, into multi-threading. We actually did multi-threading in Vaxilon, which is about the same time that Mach was doing multi-threading at Carnegie Mellon, just about the same time. So we got partway through this project, and we start thinking about, well, Scorpio has been going for quite a few years now. We don't know when it's going to be delivered. We don't really have any suitable platform to run this on. Maybe we should think about what we should do to VAX, to maybe make VAX a smaller architecture. So we started an effort within the company called microvax, and which was to trim down the architecture. And then later on, after we had developed the architecture, we thought, well, we still don't have any platform to run this on because we're going to have to produce a chip for this. And there was a microvax chip. So maybe we should start a hardware group here too, and we should produce an implementation of microvax that would not be one chip, but it would be a small system, maybe the size of a PDP-1105. So we brought some more people out from DEC East for the hardware project, and they were mainly people from the East, but we also hired I guess 3 people locally, because there's a lot of going on in this area with electronics, so it was easy to hire a few people and to produce microvax run. We actually shipped Vaxilon and microvax 1 together, and I got very interested in hardware at that time, and I ended up working on Vaxilon, pretty much writing the kernel, and the other people wrote the pieces of the file system and the pieces that went around it. But then I switched to the hardware group for the microvax 1 and wrote all the microcode.
And somewhere along the way, you hooked up with Carver Mead and took the team to learn how to do that?
The way that we implemented the microvax 1 system was, Gordon thought it would be a good idea if we tried some new technology with respect to producing silicon chips. And one of the new technologies that was being touted by Carver Mead from, was he from Caltech?
Caltech. Mm-hmm.
And Lynn Conway was some silicon compiler tools, and they're the company that was founded, actually called Silicon Compilers, that Carver Mead was a principal in, and John Hennessy was also. And we got together with them and spec'd a chip that they could build that would be the central processing unit of the system, and it would be on one chip. And so they produced the chip. They designed the chip jointly with our specifications, going back and forth. They didn't have all the expertise, and then our hardware guys designed all the hardware that went around that. We had an awful time getting the chip built. We went to a company called AMI to start with, which, in those days, semiconductor companies were popping up like dandelions. There were lots of them. They'd pop up, they'd run through their VC funding, they'd lie over, roll over and play dead. AMI never actually produced a chip for us that worked. They produced a chip, and we got the chip and we looked at it, and they had done all the maths backwards. They were all the negative of what they should be.
Oops.
Oops. So I don't know how that happened. So we went to another company called Seek. Mm-hmm. And Seek actually produced the chip. I can't remember us having any problems with the chip with respect to errata. there may have been some things that we worked. I don't really remember. I remember it being pretty much bug free, and we were able to take that chip and we put it in a QBus based system, and that was microvax 1. And we ran Vaxilon on it, but later on we also ran VMS on it. Partway through the microvax architecture discussion, we had trimmed the memory management capabilities of VMS quite a bit. I'm not VMS, the memory management capabilities of VAX way down, which meant that VMS would not run with it. It would have to be big modification to VMS to make it run. And so I was writing the microcode, and I was thinking, geez, why don't we just do the full memory management? It's not much microcode. So I got Bob Sutnick to agree to that. He was the guy that was doing the microcode for the microvax 1 chip, that we just do the whole thing. It was going to be less work to do that than not do it, and we get VMS to run. So we got VMS to run almost at the same time we got our system to run. And I don't remember exactly the year. It was probably 86 or something, 84, maybe 84. About 3 years, maybe 3 years in development for that system. So that was our first project at DECwest.
And where did that lead to?
Well, that led, what did that lead to? That led to problems. That led to big problems, because here we are, now we have this kind of seasoned operating system group. We have the seasoned hardware group. Now what are we going to do? And so the problem is to try to find something to do that's not being done by another group at headquarters. And so we went through several proposals on building projects, or building systems. Hardware was mainly hardware. There were some people at DECwest that wanted to build a workstation. And then there were some people that wanted to build a more capable system than the workstation. And we ended up not building the workstation, and we ended up trying to build a bigger system. And that led to big problems, because we were always over the top. We're always duplicating some function that, or some part of the price performance space that somebody at headquarters was already doing. So we went through several projects trying to find the right VAX to build. And we basically, I would go back to Maynard and try to negotiate what we should build and get some degree of buy-in, and come back, and we worked for 6 months, and then Maynard would decide, well, that wasn't what they wanted us to build, so we had to find something else to build. So this sort of led to us thinking about, RISC was becoming very popular at that time, and it was kind of getting to the point where there's a lot of publicity about RISC having better performance than VAX, and RISC was the way to go. And so we got interested in RISC, and there were several RISC projects going on in the company. There was one going on in Marlboro. There was one going on down in the Bay Area at WRL, which was the Western Research Lab. And we were sort of working on one. So Jack Smith, who was the Senior Vice President of Engineering, said, DECwest is responsible for the RISC architecture. So there started the Prism project, which was a new RISC architecture for DEC. And I think we probably started that in about 85, I think maybe 85. So that's what happened after we were very successful in being, I mean, just tremendously successful. You know, very low overhead, very few people. We got things done in just record speed, record amount of money. Engineering NRE costs were like zilcho compared to the other projects. But then into a period of not being able to find the right thing to do, and then into the architecture, the new architecture.
All right, so I guess it was kind of a RISC war that started to evolve at DEC between various parts of the company.
Well, the reason that the Prism architecture actually got assigned to DECwest was because there were so many projects going on in the company, trying to develop RISC projects or RISC architectures. And of course, digital already had, we had the 36-bit line, which is a PDP-10, and then the DEC System 20. We had the VAX line, we had the PDP-11 line. I don't think we were probably making any 9s and 15s. We may have still been shipping a few 8s by then, but so we really didn't need 3 or 4 new RISC architectures. So the Prism architecture started out much like the VAX architecture with representatives from VMS had a representative, Hudson, which was the semiconductor branch, had a representative, Marlboro had a representative. One of the guys that worked on that architecture was there. We had myself, and then we had a guy from the architecture group. And we then spent the next 3 years, just about 3 years, going through a revision of this and then taking it back to the senior technical community, and they would look at it and say, oh, we don't like this, and we would go back. We flipped from 64 to 32 to 64 back to 32 in the architecture, which it took a long time to sort through all that. And then the whole principle of RISC was to produce a system architecture that was easy to implement. You didn't have to have brute force methods of doing things and massive verification suites. But then the company kind of ran off the track and started adding all these things. The first thing that happened is we got to have vector arithmetic. So we have to compete with Seymour Cray. So we had to have a vector architecture. Well, Seymour probably had, he probably had 8 vector instructions. Well, we had to have 150 vector instructions. So, and they had to be long vectors. They weren't short vectors. And so this went on and on and on. And at the meantime, at DEC West, we're sort of gearing up. You'd think that we'd be in a holding pattern, but we're not. We're sort of gearing up for building one of these systems. And we have proposals for building these systems, and we took microvax 1 and we actually converted it to run Prism code so people could actually develop software. And we came to a point where finally the company just said, we're canceling Prism. And I went through we went through a lot of iterations. I'd go to Maynard, try to get some consensus on what we should be doing. I'd come back home, and invariably it was always something bigger, and we'd add people. So we kind of grew from like 20 people to 180 people. So we have this 180 people organization, and we're building kind of a nebulous project or nebulous product based on this new architecture at a time when the company was trying to build 3 of these machines. There was one in Marlboro and one in Littleton and one in Seattle. So our machine got canceled, and our system our operating system, which is called Mica, got canceled. And I sort of I kind of went through the stages of trying to find some ground where we could all agree on what we're going to build, come back, I'd sell the people on it, and then they get disappointed. So I said, I don't want to do this again. So I said, what am I going to do? And I said, well, I guess I'll form a company. So I got 3 other guys and I together. These are the same 3 guys we met with. I was talking earlier about Ballmer, which we'll get into later. And we decided we were going to form a company to build servers. And I formally quit, although I didn't leave right away. They gave me an office somewhere else until I had really settled things. I spent a lot of time traveling back and forth to the valley, talking to the VC and what we're doing and whatever. And we actually got to the point where we had the VC all lined up. We had 3 VC and MIPS. They were all going to put up some seed money. We were going to have $1 million worth of seed money, which was probably quite a bit of money in today's dollars. And this would have been in 1988. So somewhere during this period, quite a few of the people, when Prism was canceled, had decided that maybe they'd look across the street at Microsoft and go to Microsoft. And one of the people that went over there had been talking to Bill Gates about the group at DEC West, and that we had a good operating system group, and maybe that would be something that he might be interested in. So there was an interview arranged, and I went over and talked to Bill about what they were interested in doing and what they wanted to do, and see if I was interested. And their basic concern was that Intel was not bringing the x86 architecture forward fast enough, and that RISC processors were going to overtake them, and if RISC processors overtake them, then all the PC software that they developed wouldn't be valuable anymore, and that they ought to have something going on in RISC, and if they were going to have something going on in RISC, then they needed a new operating system that wasn't written in assembler, that was written in a portable language, so that they could run across several different architectures. And so I sort of listened to all of this and was really interested in doing my own company. And so I kind of left the interview thinking, well, I don't think I'm real interested in this. And sort of, time kind of, I don't know, over a couple months, we mulled this all over, the four of us, and finally we got all the VC lined up, and we got the commitment from for the money. And before we got the commitment, boy, you listen to them talk, we were the greatest people in the world. But as soon as we got the commitment, our value seemed to diminish a little bit, and they were a little bit more vocal about whether or not we could actually run a company or not, whether we'd be able to develop a product, even though we had a good history of product development. So that sort of got under my skin a little bit. And about the same time, Steve Ballmer, who worked at Microsoft, and he was the head of the finance department at Microsoft, called and said, Howard, what are you thinking? And I said, well, I'm thinking that we're really close to doing this company, and we're probably going to turn down I'm probably going to turn down the Microsoft offer. And he said, oh, geez, won't you give me a chance to convince you otherwise? And I said, well, yeah, okay. And he said, well, how about breakfast at Denny's, on Saturday morning at 7 o'clock? Or, I don't know, maybe it was a Sunday morning. But it was early. And I said, yeah, okay. So the four of us went to Denny's and sat down. And Steve is such an energetic guy and a positive thinker. And so he starts the sales job. And I guess the best thing you can say is he fleeced us. Because by the time we left, we're all ready to sign up. And we did. We decided not to form our company, which I think was a great, looking back on it, we would have been just another server company probably, unless we could have developed some, in fact, we were really founding was a hardware company. And unless we would have had the foresight to convert that company quickly to a software company, we would have been in trouble. So, in fact, an interesting thing you might find interesting here is we actually were going to run Unix on this box because of the lead time that it would take to actually produce something of your own, and the fact that it would be incompatible with everything. So obviously we couldn't produce something that's VAX compatible, so the next best thing was Unix, and we decided that Mach was the best example of a Unix system. So we're actually going to use Mach on this server. But anyway, Ballmer fleeces us, and we all decide to sign up and go to work for Microsoft. And so, I quit immediately. They're still working for DEC, and I quit on Friday and joined Microsoft on Monday, and the following Monday, these other three guys follow me. And then from there, I don't want to say we recruited, because we didn't really recruit people, but people ask us about opportunities. And of course, we're forthcoming about opportunities. So we managed to bring over quite a few people. And part of the thing about going to Microsoft was they wanted the portable operating system, but I liked the hardware part of it too, having that. So I convinced them that I should have a hardware group and the software group, and that we would produce, the hardware group would actually produce the first RISC-based PC that the software group would be producing the operating system for. So we were able to bring over, I'm sorry, we weren't able to bring over, we were able to satisfy the...
I think the statute of limitations is long past.
The statute of limitations long past. We were able to bring over these people from DEC that had been, you know, the top performers at DEC West, and so we got the top hardware guys and we got the top software guys, and you know, it was about 10 or something like that, and we hired some more people. We hired, we had, part of the thing about the group was that the hardware group, not like the software group. The software group, Microsoft wanted to make sure we had Microsoft people in the software group, because otherwise we would just produce something that was the DEC cultural thing, right? So we had, actually I think we have one software guy, and he was a pretty good, he was a vocal Microsoft guy, and he had a lot of ideas, which actually dovetailed with ours pretty well, about how to build an operating system. Microsoft had been working with IBM on OS/2 for several years by that time, and that relationship was not going real well, and this guy had worked on that, so he was very happy to join our group.
So you parachute kind of into Microsoft, and after a short period of time you look around, what did you see? What did Microsoft look like at that time?
Well, Microsoft didn't look like DEC. Or actually, I should say Microsoft was a very different company than DEC. DEC was, the thing I liked about DEC, and I think that I can honestly say that I spent most of my the most enjoyable engineering years at DEC between 1971 and 1980, or maybe 82 or 83, was DEC was mainly an engineering company. It was run mainly by the engineers. The engineers proposed the products, they talked to customers, they tried to produce very high quality products and put them in the market. And then the marketing arm of DEC was not, I would not say during those years was really strong. I think it became strong after that, much stronger, because the focus of the company became much more marketing oriented than it was engineering oriented. But Microsoft was very marketing oriented. Microsoft was, they marketed the PC software, DOS, to IBM. So they were very more marketing oriented, which, you know, I thought was, I liked that because I liked it and I didn't like it. I liked it because it was going to be, I was going to have a group of marketing people that were really going to be out hawking the projects or products. On the other hand, I didn't like it because they might have their fingers in what we were going to do. And it turned out that the original version of NT was pretty much an engineering driven thing, except for a couple of things, and that was that in addition to being portable, Microsoft wanted the system to be compatible with multiple operating environments. So that sort of led us to an architecture within NT that would allow different subsystem personalities, and so we had to keep IBM happy and run OS/2. Of course, we wanted to run DOS. And then the other thing that was big was very popular. It was popular, was POSIX. These are the standardized Unix interfaces. So the personality of this thing was going to be this multifaceted thing. See, I'm trying to think, why did I go down this route?
Well, it was kind of like you
we're dropped in.
Drop in. And
so anyway, the Microsoft people, or Microsoft, sort of dedicated that level, but none of the rest of the level. The rest of the level was pretty engineering driven, and we set about designing Windows NT much in the same way that we had set about designing VMS, except that in terms of Windows NT, we decided to produce a much more detailed specification of the system. And VMS, we had this small group, and we spent a lot of time talking about things, and we did do some specs, but they were pretty rudimentary specs. For NT, we wrote a humongous spec, and I'd say it was over 6 months, about how the whole system would work, so that people could pick up the spec. As new people came in, they could pick up the spec and understand it and read the code and actually kind of understand what was going to go on. Our first projected delivery date for the OS was like 2 years. Now, it actually took us 5 years to produce the first OS. I could have never, if you'd asked me even today if it would have taken 5 years back then, I would have said no, and so we can do it in 2 years. But there was so much more to do. VMS did not have a graphical user interface. We had to do that. We didn't have the subsystem problem in VMS. We are running multiple personalities. We had to run the PDP-11 binaries, and we produced what was called the AME, which was the Application Migration Executive. And we ran in fact, that's how we got the VMS software out, was by running the 11 software on VAX.
Completely unconstrained architecture in the I/O and so on,
right,
in the PC
right
world. Yeah.
And so we had a lot more to do, and we started out with this this idea that we're going to produce the first RISC PC, and we're going to produce the software for it, and we make this. Well, I can't say that we make this mistake. This mistake has already been made for us when we get there. Is Intel at the time is producing the i860, and this is one of the fastest RISC machines in certain applications, and those applications are mainly graphics. So Microsoft wanted to use that as the microprocessor for our first reference implementation. We were going to build a reference implementation of the 860, and we got one of the OEMs, which was Olivetti, that signed up to build this. So we were going to build the reference system, and they were going to take the design, make it manufacturable, and manufacture it. We were going to build the software. But then, partway through that, we found out that the 860 was pretty sick. It had a lot of errata that would make it pretty unusable as an OS-based system. It had some quirks that made it very nice for the graphics world, but not very well for the operating system world. It had a virtually tagged cache. So basically, every time you switch context, you sweep the cache, because it has all the virtual tags from the last address space you ran in. So anyway, it took 5 years to do the first version. So I guess your original question was, how different was the environment? Well, the environment was a lot different, because DEC was an engineering run company, and we're always based on engineering excellence. Microsoft, I think, justifiably, I would say, is a marketing-based company, and they weren't based on engineering excellence. So there was sort of a little clash between our culture and the Microsoft culture. But I think that we instilled a lot of that into the Microsoft culture, but we still had a lot of things going on that were sort of outside our control, that were within the Microsoft culture. So it made the project a lot longer. And the environment was very different.
Somewhere along the word, you said to me, there were a lot of coders at Microsoft, but no software engineering, and you had to bring the discipline of software engineering
I think
to Microsoft.
that one of the things that we brought was the engineering discipline on building software. And I don't think that Microsoft had the engineering discipline that we had at that time. Of course, that's 28 years ago. It's a long time, and the discipline at Microsoft now is I would say, is excellent. There's a lot of stuff in place. It's not the same atmosphere that we had with the original NT team, because our team was small. We start out with 25 guys. The end of version 1 were 150, At the end of version 4, we're 400, which is big. Today it's 4,000. So.
Now, along the way, a lot of things get added to what NT is. I guess you had program managers or something. That was, I think, the title.
Yeah. As far as the culture and environment, you know, at DEC we had program managers, but program managers were they were quasi-marketing people in some sense. They didn't try to manage the engineering effort. The engineering effort was managed by the engineering people. So there was a big clash in the beginning between me and the program managers of Microsoft over who did what. And I wrote, I wish I could find this piece of mail I wrote, but I wrote this big piece of mail to our program manager about his job and mine, which laid out what I thought his job was and what my job was. And so that pretty much worked itself out because we pretty much operated the way we did at DEC. But over time, program managers at Microsoft have taken a more direct involvement and control over what happens.
So you have this enormously complicated thing, multiple platforms you're going to run on, portability, keeping control of this and keeping everybody moving for 5 years gets to be quite a challenge.
So a little bit about the complexity of what we're building. You know, we talked about the 860 and the problems with the 860. Well, partway down the road, you know, we'd only went about a year and we decided there's no way we can go with the 860. And so they said, well, what should we do? So we said, well, how about MIPS? MIPS is doing the R4000. That's the platform that we ought to make the first one. So our hardware group switched to the R4000, and we started to go in that direction. And now, just to make a lot of difference to the operating system, because the way the operating system is structured, or was structured, was we'd sort of taking the stuff that was absolutely portable, and it was still portable, and then the stuff that was hardware architecture specific was divided out so that you just had to replace that. So the first thing that happened was DEC got wind of what we're doing and says, well, geez, we're building an R3000 workstation. Why don't you support the R3000 too? So I guess foolishly we said, okay, we'll support the 3000 too. Well, that put us into some difficulty now because the 3000 is not entirely compatible with the 4000. So now we're building for two platforms. So we have the R3000 and the R4000. And not long after, I said, well, you know, it looks like it's going to be a little while longer than we thought. Maybe we should add the 386 back into the mix here. You know, Intel's coming out with, I think it's the 386 25 megahertz. Let's add that in. So now we start. We aren't building any hardware because there is the industry infrastructure to build x86 based systems. So we don't do anything there. And so now we're building for basically 3 targets and 3 operating environments and the GUI stuff. And now along comes DEC back with Alpha and says, geez, we want to run Windows on Alpha too. And so we said, okay. So we started doing Alpha. And then IBM says, well, geez, as long as you're doing all that, let's do the PowerPC. So we're doing actually 4 platforms. We're doing 4 platforms if you only count MIPS 1. If you count them 2, then we're doing 5. In addition, what happened was somewhere in the early 90s, we had this thing on the 16 that ran on DOS that was a layer. It was a program that ran on top of DOS. It was called Windows. We did Windows 1.0. The industry said ho hum. We did Windows 2.0. The industry said ho hum. We did Windows 3.0. The industry said ho hum. We did Windows 3.1. We sold 16 million copies in 6 months. It was like unbelievable. So Bill says, I guess our main operating environment will not be OS/2 anymore, it will be Windows. So we switched from our main operating environment being OS/2 with the program manager, which was their graphical interface, to Windows. And when we brought in Windows, then we brought in also all the compatibility requirements with Windows 16. So we're running on all these platforms. We're running these different environments. We're running a 16-bit DOS emulator. We're running a 16-bit Windows on Windows emulator. We're running Windows 32-bit emulators on Alpha, PowerPC, and MIPS. All those things to get to the first release. Now, the first release actually only supported MIPS and the x86. Then I think about 6 months later, we did another project called Daytona, which was another release, and that included Alpha, which was 3.5, and then about 6 months later, we did the PowerPC. So that's kind of why it took 5 years.
Oh, yeah. Easy to understand in retrospect. Lots of things changed.
Lots of things changed.
Yeah. So keeping the team going, here's the Dave Cutler infamous management style at work. Talk about keeping the team going.
Well, I said earlier that I'm always consider myself as a leader, not a manager. So I've always tried to be a leader that is part of the team versus somebody that is separated from the team. So I'm always a part of the team. If the team is stressed and up against the wall, then I'm stressed and up against the wall. So I think we didn't have any problems with people burned out. People pretty much stood the whole 5 years, although there were some ramifications. I mean, people got divorced, there are other things that happened, and we had very little attrition. I mean, just really small attrition. Everybody believed in the product. And the other thing we did was we did this every Friday night. We had a party. We called it the WIM. And the WIM was the weekly integration meeting. And it was instigated by a guy named Dave Thompson, who was in the network group, because we eventually pulled in the network group. Originally in the PC world, the network group was separate from the operating system group, and it was just an add-on. It's some other program. If you want to do network operations, you ran a program to do that. It wasn't building the operating system. And we had planned all along to build it into the operating system with the VMS model. So we're growing pretty rapidly as we're pulling in some of these groups, and we're growing from 20 people to 150 or whatever. And so he said, well, why don't we have this? We'll have a meeting every Friday afternoon, and we'll go get beer and pizza and chips, and we'll meet, and just everybody will get to know each other. So this grew into a huge thing. I mean, I can imagine 5 years, and every Friday night that you're doing this. We start out, we're in a room about this size, and we end up in a huge room. And we start out that I send the development managers. There's like 4 development managers under me. I send them down to Safeway to buy a few beers and pick up some pizza and bring them back to the end when we have full catering from Marriott. Marriott's bringing everything, and we go from, chips and salsa and beer or pizza to shrimp and all sorts of stuff that's catered, kegs of beer. I mean, it was interesting. And then there were some things where we always have something going on where we try to get people to feel better about what's going on and how much stress they're under. I know there's some people that felt they were under a lot of stress, and sometimes they break, but I think generally we held everything together pretty good.